Welcome. Today we are going to continue our study of triangle proofs by going a little bit further than we did in the last lesson. We are no longer going to stop once we have congruent triangles, but instead we're going to see where that leads us and what things we're able to prove based on it. To do that, we are going to use corresponding parts of congruent triangles. I'm going to start us off by just reviewing when given two congruent triangles, what are the congruencies that I can find using this congruency statement? Well, if you dig, you can identify what the congruent angles are. If I look at my statement, angle A is middle. It is congruent to angle O, which is in the middle of this statement. So I can use our corresponding parts knowledge to identify the corresponding angles and the corresponding sides. And then from that, I can just sort of process and formalize a couple of things. We talked in the last lesson about, or two lessons now, that anytime I want to prove that two triangles are congruent, I need at least three congruent parts. And so far we've talked about having all sides, side, side, side. I can do a side, an angle, and a side. I can do angle, side, angle. And we had a super short video that talked about some additional ones, the most useful of which is the angle, angle, side theorem or the hypotenuse leg theorem. Okay, so based on that, we know that I have to have three congruencies to prove two triangles congruent, but I notice there's 6 things here. So if I only have to have 3 to prove the triangle's congruent, then once my triangles are congruent, I can get 3 more congruencies almost for free. We're going to use that as we talk about something called corresponding parts of congruent triangles are congruent. And this is just the definition of triangle congruency, sort of formalized a little bit. And we are able to use this definition of triangle congruency to go a little bit further when we write proofs. This is really obnoxious to have to write as a reason in a 2-column proof. So we, being efficiency experts, call this CPCTC instead. And you can actually Google this, and it's known in the world. And so you can get all sorts of good information and definitions if you just want to type in Google CPCTC and see what comes up. We are, instead of Googling, we're actually going to use this. And I have a piece of paper here. We're going to use this to do some actual proofs. And what I've done is I've gone ahead and marked up this picture for example 1. The first thing I noticed is I was given a hint, and I was given an angle congruency. And then I also noticed that I immediately that I have vertical angles here. So in my brain, this is super easy. I'm going to prove these triangles congruent. Angle, side, angle, I'm done. Except no. Notice, I wasn't asked to prove that these triangles are congruent. I was asked to prove that angle A is congruent to angle B. Well, I don't know how to do that straight away, but as we just spoke of up here when speaking about CPCTC, we noticed that if these two triangles are congruent, then their corresponding parts are also congruent. So if I wanted to, I could show these two triangles were congruent, and then I would automatically be given that A is congruent to B almost free. These types of proofs require us to go at least one step further than we've done in the past. But they're not that much more complicated. It just requires us to do a little bit more. So let's do what we always do. I'm going to mark my steps over here. I'm going to find my 3 congruencies. I need those so that I can, second, I'm going to prove that my triangles are congruent. You like my shorthand here. And then once I've proven my triangles congruent, I'm going to use CPCTC to show other congruencies, right? And that could be an angle, it could be a side. Once I have congruent triangles, I can say a lot of things. I can say AC is congruent to BD, or I could say AM is congruent to BM. There's lots of congruencies that I can get. In fact, there's 3. We set it up above. All right, so let's dive in. AB bisects CD, and that is a hint. And I want to be careful. CD is the segment that's getting split into 2 pieces. AB is the segment that's doing the splitting. So I want to make sure that I'm careful there. This was given information, and from it, I can conclude that CD is congruent, sorry, that should be CM, is congruent to DM. That is a side congruency, and I found that by using the definition of segment, important to put the word segment, bisector. Because I'm bisecting a segment, not a The thing that we noticed was the hidden congruency, and my hidden congruency is that AMC is congruent to BMD. That is an angle congruency, and I know this because these are vertical angles. They're congruent by the vertical angle theorem, vertical angle congruency theorem. Okay, so all of that was so that we could prove that triangle AMC is congruent to triangle BMD. And I'm able to say that because I have an angle, the included side, and an angle. So this is the angle side angle postulate. And in the previous lesson, we would stop here. But I'm going to go a step further. So I'm going to go ahead and write my prove statement here. A is congruent to B. Why? Why can I say that? How do I know that? Well, I know that because I can use congruent, corresponding parts of congruent triangles are congruent. I can say this is true by CPCTC. And we're efficiency experts. I'm not going to write all those words out. I'm going to say CPCTC. And now we've proven something a little beyond just triangle congruency, and it didn't hurt too much. Want to try another one? That's a funny question, isn't it? We're going to. All right, example 2 is using, it gives me parallel lines. So are there bells going off in your head that say parallel lines, alternate interior angles, corresponding angles? It should. I'm given some clues. These are clues. And next thing I notice is I'm being asked to go a step further. So I'm going to identify my 3 congruencies. I'm going to prove these 2 triangles congruent, and then I can use CPCTC to go a step further. Let's start by marking our picture. I'm given some parallel lines. BC is parallel to AD. So I'm going to mark that with a single arrow. That's my 2 lines. They're cut by a transversal. So I'm going to have, I suspect, alternate interior angles there. I'm going to go ahead and mark that. Here's my alternate interior angle. I was also given that AB is parallel, and I'm going to use 2 to show that it's parallel to CD, 2 arrows here, right? And so in this case, I've got 2 parallel lines, slippery thing, cut by a transversal. And so I'm going to have alternate interior angles again. And in this case, they're going to be here. So there are 2 set of congruent angles. I need 3 congruencies to prove my triangle's congruent. And I remember from the last lesson that we have a hidden shared side, which is a hidden congruency. And so AC is going to be congruent to CA. And that's how I can prove my triangle's congruent. Once I've proven congruent triangles, then I know that each side is congruent and that B is congruent to D. Corresponding parts of congruent triangle congruent. Let's do this. If you'll humor me, pause your video, fill in the proof to the best of your ability, and then come back and check. See what you can do all by yourself. That's amazing. All right, did you try it? We're going to use CPCTC. I'm going to start with my given information, the first given. And from that, we're going to identify, as we already have, my alternate interior angles that is an angle congruency. And then I'm going to repeat. Here's my next given. And from that, I get another set of alternate interior angles. Why that big old thing is up here is beyond me. Go away. Whoa, that didn't go away. All right, we're just going to pretend it's not there. There we go. All right. Then finally, we said that we could use the symmetric property to come up with the third side congruency, or the third congruency, which is a side. English, it's a struggle. And from that, I'm able to say that the two triangles are congruent. Once I have congruent triangles, then all the corresponding parts are congruent, which gives me that angle B is congruent to angle D through CPCTC. Just another example of how we can go a little bit farther. All right, let's try another one. Again, I'm being asked to go a little bit further than triangle congruency. So this tells me I'll probably use CPCTC. I was given a lot of information, which is pretty groovy, and I was given two congruencies, so I'm not going to have to do as much work as sometimes I have to do. This is a hint. It's not a direct congruency. I'm going to mark my picture. M is the midpoint of AB. That tells me that AM is congruent to BM. I actually think it's a reflection, so I'm going to say AM is congruent to BM, like I did. Okay, and then I'm also told that angle 1 is congruent to angle 2. I'm told that angle 3 is congruent to angle 4. So dang, isn't this nice? I can prove these two triangles congruent by angle, side, angle. Once I have congruent triangles, then all the corresponding parts are going to be congruent, and I'll be able to say that segment AC, I'm going to mark it, oh, let's mark it in red, say a side AC is going to be congruent to BD. It's not yet, but it will be. If I do this right, CPCTC, then these two sides will be congruent using CPCTC. So that's my goal. My plan, get my three congruencies down, prove the triangle's congruent, and use CPCTC to identify AC segment is congruent to BD segment. Who says it that way? Evidently I do. All right, pause your video, fill out your proof, and come back to check. All right, here's what I came up with. You might have done these in a different order, in which case you are perfectly correct. The only order that absolutely has to happen is that AM congruent to BM has to occur after you declare that M is the midpoint of AB. And the three congruencies must appear before your triangles can be declared congruent. Triangles have to be congruent before you can do CPCTC, but there is some latitude in the order that you use for those. Hopefully that made some sense. And we are ready to try another one. It's exciting, isn't it, folks? All right, in example 5, I've got my little butterfly bow tie guy going here. I noticed, sadly, that I was not given any congruencies. I was just given clues. And I need to mark my picture. Again, I'm going to prove that C is the midpoint of AE. Whoa, jump back. Not only am I saying that AC is going to be congruent to EC, that's what I can conclude from CPCTC if I prove the triangle's congruent, but I have to go even further than we did in the last proof, and I have to then declare that this is a midpoint. So here we go. We're just adding a few steps each time. Let's mark our picture with the congruencies that we have. First thing I notice is that AB is parallel to ED. And when I have parallel lines, I make cool noises, or I could say it's, there we go. I've got parallel lines cut by two different transversals, just depending on which one you want to actually activate and use. C is the midpoint of BD. So I'm going to mark that before I get down into my angles. I could say by alternate interior angles that A is congruent to E. That would be this one. I could say that B is congruent to D. Or I could grab the vertical angles, the hidden congruency that's right there. So I actually could prove that all three angles in the left-hand triangle are congruent to their corresponding angles in the right-hand triangle. And I could be done if there was an AAA postulate, but there's not. So I do have to use this side. I can either use angle, angle, side, or I can use angle, side, angle, whichever I choose to finish this particular proof. I am going to show you the angle, angle, side version. If you look at the notes that are posted online, I used angle, side, angle. So you can see both ways to formalize this proof. Both are going to be correct. All right, let's dive in. I'm going to start with AB is parallel to ED, and that was given to me. And from that, I'm going to conclude that A is congruent to E. That is an angle congruency, and I get that from the alternate interior angle theorem. And at the same time, I also get that angle B is congruent to angle D. That's also angle congruency, and it's also the alternate interior angle theorem. And then the last thing I'm going to look at is this particular hint that I was given, which is that C is the midpoint of BD. That is a hint, a clue. It's not actually a congruence. It was given to me. But from that, I can say that BC is congruent to DC. And for that, I'm going to use the definition of midpoint to justify my statement. Once I've done that, I am ready to say that my triangles are congruent. So I'm going to label it green to orange to vertical. ABC is congruent to green to orange to middle. So those are my two triangles that are congruent. And I am, oh, I forgot to mark this. This is a side. I am going, if in this case, going to use the angle, angle, side theorem. And it's an angle, angle, side because my side is not between my two congruent angles. Just an example of how you can use that theorem. Okay, once I have congruent triangles, I know the corresponding parts are congruent. And that would let me say that AC is congruent to EC. That is a side, well, my triangles are always already congruent, so I don't have to worry about that. I am allowed to say this. My justification is through the corresponding parts of congruent triangles are congruent, which is very handy. And from this, I am now able to say that C is the midpoint of AE, which is what I was trying to prove. And again, that is by the definition of midpoint. Because remember, definitions sort of go both ways. If I'm a midpoint, I create congruent segments. If I have congruent segments, then I am a midpoint. So look, we did a fantastic proof here that went actually 2 steps further than just proving triangles congruent. It's an exciting world we live in. All right, last one. It's actually very similar to the one we just did, so I would love for you to fully and completely try this one on your own. Pause the video, and then come back and we'll talk through how to do it. All right, here's the last one. Hopefully you managed to get the same idea on paper. First thing I noticed is that this is a flip or a fold. T will correspond to V, RS corresponds to RS, and all that implies. I was given a straightforward congruency. TR is congruent to DR. Love it. I was given a hint, which is a pretty easy hint. TS is going to be congruent to VS because of the definition of midpoint. So I went ahead and used my first congruency. Definition of midpoint gave me this side congruency, and I used reflexive property to prove that these two triangles are congruent by side, side, side. I then said my two angles are congruent by CPCTC, Because my angles are congruent, I know that SR bisects TRV by the definition of angle bisector. Hopefully what you've seen is that once you have congruent triangles, there's a whole world of things that you can prove beyond those congruent triangles. Angles, sides, sections, all of those become the oyster with which you pull pearls out of. Hope you've enjoyed this. And this concludes our unit on triangles. We are next, I think, going to go back and do some parallel line proofs, because who doesn't love proofs? Until next time, have a swell